Hi everybody, and welcome to a video all about parametric and procedural modeling. I posted this screenshot on social media and it generated a whole bunch of interest, and it was just literally me playing around doodling with deformers, splines and generators and just seeing what happened. And I'm just sort of searching for future topics for future videos. But it generated a whole bunch of interest, and all of a sudden people were wondering, oh my god, is this a new R21 feature? We had people contacting the product manager demanding to know, is this R21 or are we getting NURBS? And the answer is no. This is simply made with existing tools. And it's really rather easy. And it was great to see quite a few people on Twitter trying to make their own versions, which was quite fun. So I finally found the time to make a little video explaining about how I did it. And I would also like to apologize right now, is that I've got really bad hay fever, so if I'm sniffing and coughing and snuffling, I'm really sorry, and I hope you understand me okay. So let's have a little look at the scene, and the culprit really that makes all of this particular scene possible is the Wrap Deformer. It's a great little thing, and all of a sudden you can see exactly what's going on. It's just a bunch of spherical and rectangular splines arranged in a way that the Wrap Deformer can then create a sphere. And it looks pretty impressive. And quickly threw on a little shader. I activated viewport depth of field, which Ed, our old viewport developer, did an absolutely awesome job making. All of a sudden you get a nice little piece out of nothing. Anyway, so now I'll explain how I went about it, because it is using quite a few tools all together, and it does need a little bit of thought, and it's an interesting project for those that are new to parametric modeling. And recently I also posted this, for example. This generated insane amounts of interest, which is really, really good, because it tells me that people are really interested in what cinema can do with just the parametric objects, and how we can use procedural modeling to make pretty complex shapes, stuff that even seasoned, long-time users of Cinema 4D didn't realize was actually possible. And this is pretty great, because you can go back and alter all of these parameters. You can make the holes bigger. So this particular project, at a later date, I'm going to make a whole bunch of, like a series of videos explaining how to make the holes and how to make all of this just completely procedurally, so you don't have to use any modeling tools, all generated by using parameters and procedural generators. So look out for that in a later time. So let's crack on with a fresh scene. So this particular project all starts with a rectangular spline. This all was generated with one spline. So let's create our Wrap Deformer. And the cage you get from deformers gives you a visual representation of what you're actually going to get, which is pretty handy. It also tells you when you're wrong, which you can see right now. My spline does not conform to the shape of my generator. That's because the default subdivision is set to adaptive and weird angle. It's no good for a rectangular spline at all. So if we set this to natural, all of a sudden you can see it conforming now to our deformer. But again, if we increase the number of points, we can actually smooth out, make it 20, nice round number. And the great thing about the Wrap Deformer, it has two forms. We have cylindrical or spherical, which is exactly what we want for this point, for this project. And again, we're getting half a sphere with the top and bottoms chopped off. And we also want something to look at other than spheres. We want actual surface. In this case, we used the extrude. So if we drop our rectangle, like always, into the extrude, all of a sudden we can see a surface, but we get a mess. Everything is stretched and not lying correctly, and what that tells us is that the object manager has a very strict set of priorities, and the way it's structured is very important. Or the way your objects are structured is very important. See, right now, if we check out the priorities, is that the extrude is actually extruding the results of the wrapped rectangle instead of wrapping the extruded rectangle. And we can fix that simply by dragging out the Wrap Deformer, selecting the extrude and the wrap, and hit Alt-G to group them together. Now the deformer is deforming the extrude, which we can see quite nicely here. This inside edge is exactly what we want, because if we turn back to wireframe, these lines here are representing this number here, giving us a nice curve. But again, the outside face is just a mess. And now the great thing with the extrude, it has a little magic setting that is often overlooked or forgotten it's even there. And that's the cap type. Because by default, it's always set to n-gons, which means it's exactly what you can see here are n-gons, and they don't deform. That's why you can see these sort of long triangle-y shapes in my screen space ambient occlusion, giving us a hint that there are triangles there. So if I do turn on quadrangles, for example, there is one big quadrangle in the middle, but it can't make up its mind. It can't generate and find and do that on its own without you saying to make it a regular grid, which all of a sudden we get a nice new surface to work with, and it's deforming now perfectly. That's a great start. And again, what we can do with the deformed result is telling us something, because if we undeform this now, we can see that these subdivisions are actually cubes because it's a regular grid. But when I deform it, it means I can see that there are now rectangles. So if I go into my Wrap Deformer, I want to fill in what's missing at the top and bottom, and this is down here. This is the latitude, and I can bring these up. And what's great about these is that normally you can go past what they should do, but as this is its actual physical object, you can just literally drag them and it will automatically stop at the right point, which is 90 and minus 90, which creates us a nice half a sphere with the correct subdivision now. Because it's not creating geometry, don't forget, this is a deformer. It doesn't create geometry, it deforms. And it's actually stretching them out now to the correct orientation and correct size of quad. So that goes actually for the other way. If we want to generate the rest of this sphere, this is actually not the way to do it, because it's actually stretching rather than generating geometry. So we'll get to that in a minute. Right now I'm going to create the first hole, actually. Be a good place to start. And again, this whole thing is built with splines. So I'm going to create a circle spline. I'm going to scale it down a little bit away from the edge. And so if I drop that inside the extrude object with the rectangle spline, you can see that the object manager's priorities are taking the circular spline before the rectangle spline, and vice versa if I was to change it over. But we can still see the spline. So normally what you can do is to convert those to splines by hitting C and then saying connect delete, and all of a sudden you get this absolute horrendous mess. You get a hole, but it's rubbish. Plus you also lose the ability to change parameters using the attribute manager. So let's go back a bit. But what Cinema does have is something called a connect object. This is awesome because what this does is that if you put any spline in there, any two splines or 3, 400, whatever, this connect object will actually turn them into one single spline. As you can see, straight away, immediately, we get a nice result in the viewport. And again, because it's parametric, we can actually change our subdivision types to natural, away from the ridiculous adaptive subdivision, and increase and decrease as necessary. And right now it's not so important, but later on you can, if you're using smaller circles, you don't need 7 subdivisions, for example. And you can also let's get that back up. And it's parametric as well, so we can move it around and do pretty cool stuff. Because it is parametric as well, all of these inputs can be animated. So you can actually grow holes from nothing, which is pretty cool. Animate their position, which is pretty cool. Not just for the modelers, also the motion graphics guys can have some fun with this. So let's crack on with the other half. So if you remember, our deformer doesn't generate, it deforms. So we can't use this because it's going to stretch my hole to oblivion, and that's useless. So how do I do that? So I need to generate new polygons for the surface. So my extrude doesn't do this because it just extrudes in and out, which we can see here, it extrudes the wrong way. So that means if we go back to our original rectangle, if we know that a 400 by 400 centimeter spline creates half a sphere, it's kind of logical that a width of, say, of double, which if I increase, you can see new polygons are generated rather than deformed. So if I double this, all of a sudden I get a perfect sphere. So now I have a sphere with a hole in it, which using normal modeling tools would take you absolutely ages to do correctly, and you'd never have the ability to then do this with it, which is great. And at this point I'm going to put a nice little Lambertian shader on there so it's nice to look at. And also, because it's an extrude object, this is where the magic comes in. Trying to get nice beveled edges on this with modeling polygons would be an absolute nightmare. You'll be there for hours. And that's what we do. We can simply use the extrude objects caps engine. So if we set these to fillet caps, all of a sudden we get nice filleted, beveled edges on a sphere, which would be extremely difficult with normal modeling procedures. And we can also at this point turn on our isopalms, which give us this really nice little CAD look when we're modeling. Also, which confused everyone earlier, thinking that would introduce NURBS. When all it is just being able to visually represent our parametric objects with isolines, which looks really nice. So let's crack on with the rest. We gotta still have 4 holes to make, in fact. So one of the disadvantages of splines inside extrude objects and deformers is that you can't see them anymore. They disappear. So you can't get at them. You know they're there because the bounded box is telling you that they're there. Well, this is one of the neat little trick I use, is if I select my connect object, and when I create a instance, it automatically creates an instance of my connect object. So if I replace the connect with the instance, all of a sudden I actually have my spline here, and I can see this, so I can actually now interact with my spline and see the result on my geometry here on the right hand side. So if I go to object, anyway, so now I want to create holes on all four sides of this sphere, which is pretty simple to do. With the circle spline selected, I just hit down Control and drag a copy. And you can see this in real time on our geometry over here. And what's great is because our object, our wrap object is 400 by 400, which basically means it fits within a box of 400 by 400, which means to get this circle spline on the exact axes or x-axis of this sphere, we can see in the coordinate manager, all I have to do is put in 200, and now it's exactly lined up, and we can see in our side views perfectly. And we can do the exact same on the other side. So we say minus 200, and all of a sudden we have now 3 holes. Simple as that. And all of these can be changed at will. Because don't forget, the whole point of this is to be able to do this parametric. So I've still got holes on the top, bottom and sides to do. On the back side, sorry. Let's try the back side first, because that's a bit tricky. Oh, sorry. So, yeah. So for this, we're going to use something called spline mask. This is basically bools for splines, and it's really cool. Because right now, if I sort of, like before, grab a spline and move it to the position where you think normally it would be, we can see on the actual geometry nothing happens because it's falling outside now of our sort of keeper, which is this rectangle spline. So we're losing everything. We can't really use this effect. So there is a way to do this, and we're going to have to create now a spline that includes the hole. So we'll get rid of this one, and I'm going to select my middle circle. While holding down Alt, I'm going to create a symmetry. Oh, I need a copy of this, so I'm going to drag a copy back out. And in my side view, because it's in a symmetry object, if I drag it out, my copy comes with me. And because I've got snapping actually enabled already, got to see spline snapping, I'm going to snap it to the edge of my rectangle. And at this point, this is where we can create our spline mask. And if I drop my symmetry in my spline mask and my rectangle, all of a sudden you can see now we have one spline, but it's these kind of the opposite of what we want. So in our spline mask, we can say to subtract. All of a sudden we have now this new profile shape, and if I drop that inside here, boom, all of a sudden I now have a hole at the back side of my sphere, which can also be parametrically and interactively changed at will. Great. Now for the top and bottom. Now that's even easier. You can actually use the Wrap Deformer itself, because remember right at the beginning we have the ability to change the height like this. But as you can see, it doesn't generate, it deforms. So it's actually deforming the whole sphere, which actually looks pretty cool and might be interesting for the animators and the motion graphics guys out there. But it's not good for us technical modelers. But logic would tell me that my original spline is the answer to that particular problem, because my height, well, my deformer's height isn't going to change, my deformer's going to stay where it is, but if I change the height of my original input, like this, all of a sudden, I'm getting holes in the top and bottom. And again, because my deformer doesn't move or go anywhere, if I move the spline, all of a sudden I can now control the shape of my holes at the top and bottom. Let's put that to 0. So that's basically it for the main part. So that's the hard part out of the way. And if you can remember, I had holes like literally all over the place. Well, this is where you can simply start. Let's just pick any circle, and we can, using our spline here as a guide, we can just start moving and copying, dragging. Let's deactivate our spline snapping. Then all of a sudden, really quickly, you can start making a nice pattern with our circle splines. And that's basically it. So there was no more than that. There was no trickery, there's no NURBS, and all using existing tools. I think I have the shader. Yeah, maybe. Get a nice shader on there, and all of a sudden it looks like you have a CAD model. But again, as it's all parametric, we can gain access and we can change everything at will later on. So I hope that was interesting to you. I hope it clears up any confusion, and I hope you like it. Bye bye.